about concept of regression. What is regression? So regression is nothing but it is a well-known statistical technique to model the predictive relationship between the several independent variable and one dependent variable. Suppose you want to predict a house price. How will you predict the house price? It depends upon n number of parameters. It may be the size of the site, okay, and what is the cost of the building. So n number of parameters are depends on the price of the house. Okay, so now like that, so here regression is a well-known technique, a statistical technique to predict the relationship between the several independent variable and one dependent variable. So what dependent variable is cost of house, so and independent variables is size of the house, how many rooms are there, okay, and what which on which place the site is there. Okay, a lot of parameters are available. Okay, so those things we will call it as an independent variable. Okay, the objective is to find the best fitting curve for a dependent variable in a multi-dimensional space with each independent variable being a dimension. So here, okay, so here what we are, suppose if the you know if suppose for example, one more example. Okay, so here whenever the values of independent variable is increasing, at the time the value of dependent variable is also increasing. Suppose the market price. Okay, the market price for a particular fruits. Okay, when the huge amount of fruits are there, then the total cost of the uh, price of the fruit is also increasing. Okay, so here the thing is we need to write a curve. Okay, so for the dependent variable, okay, so we need to write a curve such a way that so it should be matched with the our data points. Okay, so here for example, one more example. So here one more example. So your marks, how will your marks, when your marks will be increases? So when your study time is increases, at that time your marks will also increases. So your final theory marks, it depends upon n number of independent variables. So it may be, so how much you are studying every day, okay, and what is your grasping power. Okay, so then how you will represent the answer in the exam. So lot of things are depends on your final marks and what is the inter performance of internal score. Okay, so these are all nothing but independent variables. Dependent variable is the final your result or a mark score in a final semester. Okay, in a semester. Okay, so here when your marks will be increases, so when your daily study time increases, obviously you, your marks will also increases. If your attendance is increases, obviously your marks will be increases. Okay, so that one we will call it as a regression. Okay, so here, so what are the key steps of regression? So first thing is list all the variables available for making the model. Okay, so first we need to list the all variables, whether it may be dependent or independent variable. Okay, so here that is your mark score, so that is one variable. Final result is one variable, and how many hours studying in every hour, and what is the attendance percentage, what is the internal marks. So all those things are variables, so you need to identify all variables. Okay, so after that what you need to do, you need to establish a dependent variable of interest. Okay, so here you need to establish a dependent variable of interest. The final dependent variable is final result. Okay, so you need to identify that one. Final result, you need to identify it as a dependent variable among all other variables. Okay, so next one is examine visual relationship between the variables of interest. So what is the relationship between the variable of interest? Suppose if you are okay, so your study time increases, obviously your marks will be increases. Okay, fine. Suppose one parameter is, if that parameter increases, okay, so then your marks will be decreases, means you can leave that variable. Okay, so use examine the visual, if possible relationship, not all relationship you need to identify, just you should examine visual possible relationship between the variable of interest. Okay, and finally find a way to predict the dependent variable using other variable. So then how we will find the values of dependent variable by using the independent n number of independent variables. Okay, so these are the steps. First step is establish all the variables available in the market to make a model. Okay, then after that identify the dependent variable. If you identify the dependent variable, after that anyhow you will get the independent variable. So then after that examining the possible relationship between the variables. Okay, possible relationship, not all the relationship, there are possible relationship you can identify. You can take those independent variables. Okay, then after that finally find a way to predict the dependent variable using the other variables. Okay, so these are the 4 steps. Okay, so then here suppose if we have a given a numeric value, suppose if you have a data points, okay, x and y, okay, so if you have a variables x and y, the coefficient of the correlation is mathematically computed by the formula. So here, what is the correlation? So here, correlation is to establish the dependency of the variables. Okay, so correlation, it will tell the dependency of the variable. So how it will be nearer? Okay, to calculate that correlation, so here we will have a formula. Okay, so here x bar is nothing but a x bar is nothing but a mean of x, and y bar is nothing but a mean of y. If we have a data points x and y, so we need to calculate the correlation between those two. Okay, so then we will have a formula, this one. Okay, so that is xi minus x bar, that is x particular value minus average of that x. Suppose if we have a 5 data points, okay, x 5 data points and y data points, okay, 1 2 2 3 3 4, okay, so like that if we have a data point, so then we need to calculate the correlation of that x and y. Okay, so at that time we will use this formula. So particular point minus average of x and particular point minus average of y. Okay, so multiply with those two. Okay, so then after that and add. Okay, so then square root of summation of xi minus x bar, that is particular point minus average whole square summation of yi particular point minus average of y whole square. Okay, so we need to calculate the regression. Okay, that will give the relationship between the two variables. Okay, so here in that relationship we will have a one technique, important technique, is the linear relationship. What is the linear relationship? Okay, so linear relationship shows the strong relationship between the variables x and y. Okay, so here we have a data points. Okay, so here we have a time and cost. Okay, so here whenever the time is increasing, so at the time 10 the cost will also be increases. Okay, so here, so for example, here it is a time is 10. Okay, so then cost will be 60. Okay, so when time is 5, the cost will be 40. So when time in minutes, when time is 20 minutes, the cost will be $100. Okay, so when time is 30 and the cost will be the 140. So it means, so here whenever suppose if you are using, you are taking a rental for car or other things, so when the time is increased, obviously the cost of the particular car will be increases. Okay, rent of that cost will be increases. So then we will have a values of x and y. So here whenever the values of x is increasing, then the value of the y is also increasing. Whenever value of x is increasing, obviously value of y is also increasing. That relationship we will call it as a linear relationship. Okay, so whenever the value of x is increasing, the value of y is also increases proportionally. It means that the value of x is increasing, the value of y also increasing. Okay, the value of y is also increasing. This one we will call it as a linear relationship. Okay, so how we will build up a linear regression model. Okay, so this regression model is described as a linear equation. Okay, so here this regression model will be described using a linear equation. Okay, so here we know that here we are taking y is dependent variable and x is the independent variable. Okay, so here if we have a x is the independent variable and y is the dependent variable. So here the formula is given: y is equal to beta naught plus beta 1 into x plus epsilon. Okay, so here beta naught plus beta 1 into x, this is x is independent variable. So using that independent variable, we are deriving the value of y. So here this beta naught and beta 1 are the constant and epsilon is nothing but a random error variable. Okay, so beta naught and beta 1 are the constant and epsilon in the error variable. So here we will, example, we will predict the house of the price from the size of the house. Okay, so we will predict the size of the house, we will be the size of the, suppose if it is a 500 square meter, the our price will be 10 lakhs. When 1000 square meters, price will be 20 lakhs. When the house size is 1500 square meter, then the price will be 50 lakhs. Okay, so that is the, this x is the, so here which is the x variable, that is independent variable, is the size of the house. The price of the house will be the y, that is dependent variable. Like that we will develop the regression model, linear regression model. Okay, so then what are the disadvantages of linear regression? Okay, the main limitation of linear regression is the assumptions of linearity between the dependent variable and independent variable. Okay, so here whatever, whenever the value of x is increasing, always the value of y is increasing. Whenever value is y is increasing, means the value of x is also increasing. Okay, so but every time it's not possible. So sometimes it may be when value is increasing, y is decreasing. When your value as x is increasing, another time value y will be decreasing. Another time when value is x is decreasing, y value is also decreasing. When value of x is increasing, y is also increasing. When value of x is increasing, y is decreasing. When a value of x is decreasing, y is increasing. Very lot of combinations we have. So but every time we can't expect that linear relationship between the variables x and y. Okay, so that's very difficult. Okay, that is the main limitation of the linear regression. In real world, the data is rarely linear separable. So very rarely linearly separable. Okay, so non-linear data will have a lot of things, different varieties of data will be here. It assumes that there is a straight line relationship between the dependent and independent, which is incorrect in many times. Okay, so every time if we draw a regression line, okay, so every time we can't get this straight line, that assumption is wrong. Okay, one example I will give: hotel bill and tips. Okay, when you went for a hotel, okay, so then after that, for some members, for 100 rupees bill, some members they may give 50 rupees tip, or 10 rupees give for 100 rupees. For the, assume that for 1000 rupees, 100 rupees per tips has given. Same person, another person, for same 1000, he may give 10 rupees also. Okay, for 100, for one more, for 100 rupees bill, if another person, he may give 30 rupees tips. Okay, so 1000 rupees person, he may give 10 rupees tips. Okay, 100 rupees person, he may give 50 rupees tips. Okay, we can't predict that. So the tips is not dependent on bill. Okay, some persons they may give more tips, some persons for huge amount of bill also, some persons they may not tips at all. Okay, they may, some persons they may give small amount, some persons they may give big amount tips. Okay, so at that time this linear regression, it won't work, because in this linear regression, the value of x, value of dependent variable, value of independent variable, that is x value increases, obviously the dependent variable y is increasing, but here there is no linear relationship exists. So for that, what we need to go for some other techniques. Okay, for that we need to go for some other techniques. Okay, so here for that we will have, for that hotel and bill tips, if that data points, if there is no linear relationship, then we will go for locally weighted regression. Okay, so locally regression to overcome from the disadvantage of linear regression, we will go for locally weighted regression. What is locally weighted regression? Okay, locally weighted regression is a supervised learning algorithm. Okay, locally weighted, it is a supervised learning, data points are labeled. Okay, it is non-parametric algorithm. Okay, so it is not a non-parametric algorithm. Here, why we are calling, here there exists no training phase. Okay, we are not give training to model. All work is done during the test phase. Okay, while making the prediction, all work is done is during the test phase while making the prediction. Okay, so there is no training phase. All work is done during the test phase while making a prediction. Okay, how we will make a predictor? Okay, so here locally weighted regression is a memory based method that perform a regression around point of interest using only training data that are local to that point. So here what happens? Okay, so this is a memory based. I already told that this is the part of instance based learning technique. Memory based learning is nothing but a instance based learning. So in a previous class we had discussed KNN algorithm. Okay, K nearest neighbor classifier, like that. Here this is also locally weighted memory based technique. Okay, so here when we are calculating the regression, when you're calculating the values of dependent variable, so at that time what we are doing here, we are taking the close points, we are taking the close points of the data point. Okay, so here suppose if you have a data point, suppose if you have 100 data points are there, but I will take only 5 local data points nearer to that data point. In K nearer neighbor classifier also we are doing same thing. So we'll take the nearest data points. So like that also here we are taking the nearest data points. Okay, so we are also taking the nearest local points for a particular regression around a point of interest. Okay, so here also we are taking a local points. So locally weighted regression is a non-parametric analysis, that is the model does not learn a fixed set of parameters is done in ordinary linear regression. In ordinary linear regression, so it will learn some from fixed set of parameters. Okay, but here so it won't do all those things. So it will using low, when we are testing the data, when we are predicting the values, at that time only it will take the identifies the local points and it will calculate the distance and which one is the nearer. So then after that it will calculate the weights and it will predict the values. Okay, so here this is an example of a graph of a locally weighted regression. See here, so in linear regression, the okay, the regression line will be in straight line. So here if data points are distributed differently, so at that time, so we need to write a regression line. So it will like comes like this. Okay, so here what we will do, so we will take the for this point, suppose if this is the point, so what we are doing, we are taking the local points. See here, this when curve comes like this, so here the data points are nearer to here, so that's why we have taken a data point here. Okay, see here we will have only one data point, so that's why we have come here, and here we have a data point here, then the curve will move like this. Okay, so based on distribution of the data points, we will in locally weighted regression the curve will comes like that. Okay, here we won't get a straight line. So here also, this is also we are not getting a straight line. So just based on the density of that data points, this curve will be comes. Okay, the density of the data points, the curve will be drawn, okay, by calculating the weights and all those things. Okay, so this one we will call it as a locally weighted regression. In linear regression, the data will be, a line will be in the straight line. Here we won't get the straight line. Based on the density of the data points, we will take the local data points and we will calculate the weights, and after that we will write the line. What are the steps? Okay, so here in this local, what we need to do? So here minimize the squared error over just the k nearest neighbor. So here we will minimize the data points distance. Okay, so that one we will do this. So here what we are doing, we will minimize the squared error over just the k nearest neighbor. Suppose I am taking the 8 data points as a nearer data points. Then after that, what I need to do? I need to minimize the distance between the data points. One thing, first thing. After that, what we need to do? We need to minimize the squared error distance. Then we need to minimize the squared, that is distance, over the entire data set of the training example. First thing is, for local points, we need to minimize the data point distance. After that, we need to minimize the squared error over the entire data set. Okay, we need to minimize the, that is, squared error is nothing but a distance. Okay, so that error should be minimized. Distance error should be minimized in these two. First thing is local points. After that, whole training data set. We need to do all two things. Okay, so here one more thing is, in this local weighted regression, we need to smooth the kernel smoother. So what is kernel smoother? A kernel smoother is a statistical technique that to estimate the real valued function as the weighted average of neighbors observed data. Okay, so here kernel smoothing, what it will do, it is a statistical technique to estimate the real valued function as a weighted average of neighbor observed data. Suppose if we have 8 data points, so from the data points we need to find the weights. Okay, so we need to find the weights, and that has a we need to estimate that the real valued function is, that is, we need to estimate the real valued weights. Okay, so then we need to smooth out that. Kernel is nothing but a central point. Okay, so we need to find out that central point. Okay, so the weight is defined by the kernel such that closer points are given higher weights. Okay, so how will smooth? So we calculate the weights. How will smooth? We need to give higher weights for closer data points. Okay, so suppose distance is 1 centimeter, then we will give the more weights. If the distance is 2 centimeters, then we will give lesser weights. Okay, so the estimated function is smooth, and the level of smooth is set by a single parameter. Okay, so here, so we need to smooth out the weights by giving the, which one is having the lesser closer point, we are having a higher weights, and with if the data points are, distance is more, then we will give the lesser points, the distance, the points. Okay, so these are the steps of locally weighted regression. Okay, so first thing is, what we need to do, we need to calculate the distance between the data points. So if I take 8 data points, okay, so I need to calculate the distance between the data points. First thing. Second thing is calculate the weights of the data points. Okay, second thing is calculate the weight of the data points. Then after that, smooth out the weights. How you smooth out the weights? Giving the higher weights to closer data points and giving lesser weights to lower data points. And finally, predict the values using locally weighted regression model. So these are the weights of the steps of the regression. First one is calculate the distance between the data points and calculate the weights of the data points. Okay, so for the local data points, first identify the how many local points do you want. Then after that, calculate the distance between the data points and calculate the weights of the data points. After that, smooth out the weights, and after that, predict the values using the weight regression model. Okay, so these are the steps of locally weighted regression. Okay,